Okay, so as promised, picking up Friday with grouping. So grouping is when you have four terms. That's how you know you're going to have to group things. That's weird how that's writing. Four terms. The result is going to be two binomials. Um, all of these are nice and easy because none of them have subtraction. That was a problem on my part. Let's do number 3. I don't know. So what we're going to do is you group the first two terms together and you group the second two terms together. And I look at the first two terms and I take out the greatest common factor. So the G, C, F. So what can I do between the 6 and the 3? I can take out a 3 and I can take out an x squared. What's left over? A 2x minus 1. Okay, then what? Then I look at the second pair, the 4x and the 2. What can I take out? I can take out a 2 and I'm left with 2x minus 1. Ooh, yay, these match. So what does that mean then? I'll have a 2x minus 1, and what's left over? The 3x squared and the plus 2. And that's factored. All right, so you're going to group those other 3, the first 2. I didn't have a subtraction one, so I'm going to have to make sure that I remember to talk to you about that. So who's going to remind me? All right, somebody remind me, especially if you're the group that has to watch the video. And last but not least is difference and sum of perfect cubes. Now, I believe you've done this already, but I'm going to walk us through this. This one, remember we had difference of perfect squares. Here we have a difference and a sum of perfect cubes. So some perfect cubes. 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125, and so on. All right, so if we look at this, I'm going to look at let's do number 2 because it's kind of simple. Here we have a sum, so I'm going to look in the sum category. Now the only difference between these two formulas, the difference and the sum, is the addition and subtraction at the beginning, and then the addition and subtraction on that second term. The rest of the formula is exactly the same, whether it's a sum or a difference. So when we factor this, again, we're going to look at number 2. When we factor this, we're going to end up with a binomial, 2 terms, and a trinomial, 3 terms. So I kind of just set it out in spaces. In the first spot is going to be the cube root of the x cubed. Cube root of x cubed is x. In the second spot is going to be the cube root of the 27. Cube root of 27 is 3. Then what? The first two spots, the first of the binomial and the first of the trinomial, have to multiply to give me the first spot. So x times what will give us x cubed? X squared. And then the second spot, or I guess the last two spots, the last spot of the binomial and the last spot of the trinomial have to multiply to give us the last number, the 27. So 3 times what is 27? 9. To get this middle value here, the green spot, the middle one of the trinomial, you multiply the first two. So x times 3 is 3x. Okay, that's the same no matter whether it's a sum or a difference. Then what? Then we need to put in the signs. So since the signs of our original were addition, I will have addition first. It always ends in addition. These two signs are opposites. So since I started with addition, I'll have subtraction there. If I had started with subtraction, then I would have addition. And again, the last one is always addition. So that's how that works. Now, if you like to memorize formulas, feel free to memorize that formula. I personally, not a huge fan of memorizing formulas, so I'd rather just understand what needs to go where to make it work. All right, let's try one more. Let's try number 6. Okay, so when I look at number 6, I've got 27x to the 6th plus 8. 27 is a perfect cube, x to the 6th is a perfect cube, and so is 8. So I'm going to need a binomial, 1, 2, and a trinomial, 1, 2, 3. And I just kind of think of it in terms of slots. All right, so let's look at the 27. The cube root of 27 is 3. The cube root of x to the 6th, 6 divided by 3 is going to be an x squared. X squared times x squared times x squared gives us x to the 6th power. Then what? Then I look at the 8. The cube root of 8 is 2. Okay? The first slots have to be multiplied together to give me the first slot. So 3x squared times what will give us 9x to the 6th. Ugh, said that wrong. Giving you the answer. 3x squared times what will give us 27x to the 6th. I need a 9x to the 4th. Then what? Then the back slots, they have to multiply to give us the back number. 2 times what will give us 8? I need a 4. Then, to get this middle one, to get the middle term, we multiply those two together. When we multiply those two together, we get 6x squared. Then what? Then we have to deal with the signs. This is addition, so this is addition. The last term is always addition. These two, I'm out of colors here, these two are always opposites. So since I started with addition, this will be subtraction. So then my factors would be 3x squared plus 2 times 9x to the 4th minus 6x squared plus 4. As long as there is no GCF, then this will never factor. So you don't have to mess around with trying to factor it like a trinomial or a split middle term or anything like that. As long as there was no GCF, that trinomial will not factor. Okay, and then last but not least on here, I have some combinations. So you may have to factor it once, you may have to factor it twice, or do I here 3 times? Okay, so I've got, what do I have here? I've got 8 of those in there. I'm going to let you guys try those all on your own. So always start with greatest common factor first. So always start with the greatest common factor. After you pull that out, if there is one, then you can move on to trinomial factoring or factor by grouping or something like that. But all of these will factor at least twice, maybe not the whole thing, but maybe when you factor it into 2 binomials, one of the binomials then factors again. Okay, so you're going to try those on your own. Hopefully you do well. This takes you through the weekend. You've got the half day on Friday, and then you've got no school on Monday. So I'll see some of you again on Tuesday. Have a great weekend, folks. Bye.